Today's quiz problem said that a pendulum, let's imagine that this is a pendulum and it's hanging at equilibrium, and we pull it back from equilibrium, from whatever its equilibrium point is, and it requires 3 pounds to pull it back 3 inches from some point. And then it requires 9 pounds to pull it back 7 inches. So a 3-inch pullback takes 3 pounds, a 5-inch pullback takes 3 pounds, and a 9-inch pullback requires 7 pounds of force. You know, when you pull back on a hanging weight, imagine this thing's a heavy weight hanging from a ceiling by a thread, that the further we pull back, the more force we have to exert. The problem was to find an equation for the function that describes, for the linear function that describes that force in terms of the pullback, and then to use that equation to answer a couple of questions. Questions being, when the displacement is 15 inches, what should the force be? When the force is 13 pounds, what should the displacement be? We can sketch a graph of force versus pullback, where x is the pullback in inches and y is the force in pounds. We locate the points 5, 3 corresponding to the 5-inch pullback and the 3-pound force, and the point 9, 7, the 7-pound force with the 9-inch pullback, and we find the equation of a linear function through those points using the usual methods. We calculate the rise and the run. 4 inches, 4 pounds gives us a slope of 1. That's 1 pound per inch. I didn't have room to put the unit in here, but it would be pound per inch. Then between the point 9, 7 and an arbitrary point x, y, the run is x minus 9, the rise is y minus 7. So we have a slope of y minus 7 over x minus 9, which must equal the slope of 1 if the point x, y is to lie on the line, giving us our slope equals slope equation, which we easily solve for y and obtain y equals x minus 2. Now, recalling that y stands for the force in pounds and x for the pullback in inches, we write a meaningful equation. Okay, y equals x minus 2 means, since y is force, that force equals x is displacement, so it's displacement minus 2. Actually, that would be minus 2 pounds if we wanted to keep the units on, which is a good idea, but I didn't want to push it quite that far on this example. So a displacement of 15 inches, a displacement of 15 down here in the graph, x equals 15 corresponds to displacement of 15 inches, gives us a force of, well, if we take force equals displacement minus 2, plug in 15 for displacement, we get force equals 13. Similarly, if the force is 13, that implies by the equation that 13 is a displacement minus 2, and we get, coincidentally, a displacement of 15.